Greetings and welcome to the O-Level Revision series. This is part 3 of the chapter on logarithms, and in this video we are going to apply what we have learnt in the previous video, which are the laws of logarithms, and we're going to use them to solve log equations. But be very careful, in this video there's going to be a lot of heartaches and rejection. The success criteria for this lesson would be for students to be able to apply the laws of logarithm to solve both exponential and logarithmic equations. So far, we've learned that logarithms is just another way to write an equation that we know in index form. Say we know that y equals to a to the power of x. In log form, we make x the subject and we say that x is equals to log base a of y. You can also think of this as a to the power of what gives me y? Well, a to the power of x gives me y. So that's what log is trying to say. So a few things we have to take note of is that the base a cannot be 0, 1 or negative, and the y cannot be 0 or negative. You cannot take log of 0 or of negative numbers. In the previous video, we've also covered the laws of logarithm. So the first law states that if you add two logs of the same base together, you will multiply the x and the y. So log base a of x plus log base a of y gives us log base a of xy. So this is the product law. The quotient law, in this case, when you subtract two logs, you will divide x by y. So this is the quotient law. And these two laws stem from the inverse law of addition and subtraction. The next law, the power law, states that if you have log base a of x to the power of n, you can take out n as the coefficient. Next, if we have log base a of b, we can use the change of base law. So the b will go up, the a will go down, and we can introduce a new log of a different base. So it's log base c. Lastly, in the reciprocal law, we can just set the base c to be equals to b, and we'll get 1 over log base b of a. Moving to exercise 1, solve the following equations. Part A, 3 to the power of x plus 1 equals to 2 cubed, and part B, 4 to the power of x plus y equals to 5 to the power of 2x minus 3. Pause the video here and give this question a good try. So two things you're able to do, you can take out the plus 1 as a times 3, and you can simplify the 2 cubed as 8. Next, you bring the 3 over to the right hand side, so we get 8 over 3 on the right hand side. Then you can convert this in this equation into its log form. So 3 to the power of x gives me 8 over 3 is the same as log base 3 of 8 over 3 gives me x. The base still remains as 3. Now, your calculator isn't able to evaluate log base 3 of 8 over 3. I don't think you have a log base 3 button. So we need to do a change of base. And I've chosen the natural log, so ln of 8 over 3 divided by ln 3. Now, you could have chosen the common log as well. If you key in common log or log base 10 of 8 over 3 divided by log base 10 of 3, you would still get the same answer of 0.893. But it's also a good practice to check if your final answer is correct. How do we know if 0.893 is correct? We substitute it back to the original equation. You'll see that 3 to the power of 0.893 plus 1 gives me almost 8. So if I check if your calculator is 8.001, you know you're right. So same as before, except that in this question we have x in the power of 4 as well as an x in the exponent of 5. So what we want to do is to isolate these x. So we can take out the plus 1 and the minus 3 first. So the plus 1 will become a times 4, and the minus 3 in the exponent of 5 will become a divide by 5 cubed. Next, we bring all the x over to one side. So the terms that have x, let's bring it together. So we have 5 to the power of 2x divided by 4 to the power of x, and those terms that are independent of x, the 4 and the 5 cubed, we bring them over to the right hand side. Now we'll extract out the x. We'll get 5 squared over 4, whole thing to the power of x. So that's 25 over 4 to the power of x. Gives me 4 times 5 cubed is 500. And you can see that this is what we want. Same as in part A where we got 3 to the power x equals to 8 over 3. Now we got 25 over 4 to the power of x gives me 500. Then we change in this equation into its log form, then do a change of base. We'll use the common log this time, so log of 500 over log of 25 over 4. Press the calculator, you get 3.39. Now I'm not going to show you the checking for this question, but you should, as a good practice, sub 3.39 into the original equation and see if the left hand side is almost equals to the right hand side. Moving on to exercise 2, we have two equations here from the O-Level 2020 and 2021 paper for you to try and solve. Why don't you pause the video here and give these two equations a good try. So the trick for exercise 2 is we're going to use substitution methods. First, we are going to let p equals to e to the power of x. So we're going to substitute all the e to the power of x with p, and that will give me p times p plus 1 equals to 3/4. And if I simplify this, I get a quadratic, and I can factorize this quadratic and find the value of p. Now, please do not stop here. The question did not ask you to find p. The question asks you to solve for x. So you need to continue and evaluate x. So since p is equals to half, that means e to the power of x equals to half. E to the power of x is also equals to negative 3 over 2. Let's take the left hand side first. So e to the power of x equals to half. I can just take the ln, so express it from in this form to logarithmic form. X is equals to ln half, and I get an answer of negative 0.693. But what about the other solution, e to the power of x equals to negative 3 over 2? Well, if I take ln of negative 3 over 2, I don't get an answer. You cannot take log of a negative number, so it's rejected. So please indicate why it's rejected as well. Note that you cannot, you have to write something, a reason like you cannot take log of a negative number. For part B, we'll use the substitution method again. We'll let p equals to e to the power of y. This will give us 3p plus 5 equals to 2 over p. Again, we can simplify this into a quadratic equation, factorize it, and solve for p. For p equals to 1/3, we can convert this to e to the power of y equals to 1/3, or e to the power of y equals to negative 2. Next, we'll convert both these in this equation into its log form. For ln of 1/3, you can calculate this, you'll get negative 1.10. But for ln of negative 2, you cannot take log of negative numbers, so you have to reject it. Do not forget, we should also check our answer. So negative 1.10, we can substitute it back to the original equation and see how close we are. So the two numbers get very close. We know that we have solved it correctly. Exercise 3. Solve the following equations. Pause the video here and give this a good try. Let's look at part A first. So we can use the product law and we can combine the two logs on the left hand side together. So I'll get log base 2 of x times x minus 6. Next, the equals to 4, the 4, I can convert this to log base 2 of 16. You see, 2 to the power of what gives me 16? 2 to the power of 4 gives me 16. So log base 2 of 16 gives me 4. Now that I have a single log on both sides, I can remove the logs. I can do a comparison. X times x minus 6 must be equals to 16. This will be simplified into a quadratic. Factorize the quadratic, solve for x. But are both answers valid? So let's check. If we substitute x equals to 8, well, it will check out. But if we substitute x equals to negative 2, we would end up taking logs of negative numbers. That's not allowed. So we have to reject it. In part B, we can first take out the 3 in the power for log base 3 of x. We can also take out the 3 in the power because 27 is 3 cubed. So we're going to get, when you apply the power law twice, we'll get 3 log base 3 of x plus 3 log base x of 3. Now, the log base x of 3, we can do a reciprocal law, and we'll change it to 1 over log base 3 of x. So the aim here is we want to get everything in terms of log base 3 of x so that we can use the substitution method. Now we let p equals to log base 3 of x, we'll get 3p plus 3 over p equals to 10. We have a quadratic in terms of p. We factorize the quadratic, solve for p. Don't stop here. Continue, substitute p equals to log base 3 of x to get rid of the p. We'll get log base 3 of x equals to either 1/3 or 3. Next, we convert the log equation back into its inverse form. So we'll get x equals to 3 to the power of 1/3 and x equals to 3 to the power of 3, which is either the cube root of 3 or 27, and we're done. Exercise 4. 2 more past year O-level questions taken from the 2020 and the 2012 paper 2s. Pause the video here and give these two equations a good try. Okay, so first thing we can do for part A is that since we have 1 over log base 8 of 2, we can use the reciprocal law here. We will get log base 2 of 8. And we see the 1 in front, we can change the number 1 into a log as well. So log base 2 of what gives me 1? Well, log base 2 of 2 gives me 1. Next, we can apply the product law and combine the 3 logs on the left-hand side together. That will give me log base 2 of 2 times 8 times y, so that's 16y, equals to log base 2 of y plus 3. We can, by comparison, the 16y equals to y plus 3. So 15y equals to 3 and y equals to 1/5, and we're done. Okay, so for part B, it's a bit long, but the aim of the game here is to make them all into log base 4. But the first thing I see is that I can apply the power law. I can take out the 3 in the x cubed. The power 3 will become a coefficient 3. And I also see that on the right hand side, I have 1 over log base 3 of 4, so I can use the reciprocal law here. This will give me back log base 4 of 3. So log base 8 is the only exception here. The rest are all log base 4. So to make them all the same base, I can apply the change of base law. So log base 8 of x will give me log base 4 of x over log base 4 of 8. Next, I can simplify log base 4 of 8. 4 to the power of what gives me 8? Well, 4 if I square root it gives me 2, and 2 if I cube it will give me 8. So it will be 3 over 2. 4 to the power of 3 over 2 gives me 8. I can further simplify this because 3 can be divided by 3 over 2. This will give me 2. And now that I have almost all base 4 logs already, I just need to bring the 2 in as the power for x squared, because I need to use the quotient rule to combine the left-hand side. Applying the quotient rule, I'll get log base 4 of x squared plus 5x over x squared equals to log base 4 of 3. Then I cancel the log on both sides because this is a comparison. And I will get a quadratic. But this is a super simple quadratic because I'll get 2x squared minus 5x. There's no constant term. I can just factorize out the common factor of x, and x is equals to 0 and 5 over 2. Now if I sub in 5 over 2, it will check out. It works. But be very careful. What happens if I sub in 0 back to the original equation? If I sub in 0 here, let's say, I'll get log base 8 of 0. Can we take log of 0? We cannot. So we have to reject it because we cannot log 0. With that, we are done with this lesson. Let's reflect on the success criteria that we've set out at the start. Are you now able to apply the laws of logarithms to solve exponential and logarithmic equations? So if you have any questions on this lesson, you can post your comments in the comment section below. With that, we've come to the very end of part 3. Do stay tuned for part 4. We'll be looking at logarithmic graphs as well as mathematical modeling involving exponentials and logarithms. Thank you and have a great day of learning.